So what happens if you equip firework with some additional scientific payload? I'm Timo Denk, let's find it out. There was a lot of payload which had to fit into the capsule. First of all, the power supply and the Arduino Nano, which is hidden below it. You can see it here. And secondly, the SD card logger. This is a SD card breakout, and the data of the sensors will be logged on the SD card. Below those wires, this is a pressure sensor. It's used to measure the altitude during flight. And this is the voltage converter to convert the 8.3 volts from the battery to 5 volts for the Arduino. This one here is an accelerometer to measure the acceleration of the rocket in flight. Fitting all the parts into the capsule was not that easy, and as you can see, I used some aluminium foil to protect the payload from fire. I didn't need the explosive stuff, so I simply cut it away and used that space for my payload. So after some tweaking, everything fit nicely into the capsule. When I remove the cap, you can see that there's the voltage converter on top and all the stuff around it. There's the accelerometer, and on the side here is the power switch, which enables the whole system. The last step was attaching the launch stage, and after that we were ready to take off. Let's go! Here you can see my friend Ruben, who fired the rocket, and at this point shout out to him for his assistance. Let's have a look at the data. There are 4 columns with measured data. Those 3 represent the acceleration. This one is the altitude, as you can see. And you have to know that the units for the acceleration are 1/100th of a g. So this means we have 0.09 g, which is the normal acceleration when you are on Earth. And that's the whole time until the liftoff, which is over here, where the acceleration increases extremely up to more than 7 g. And at this point I have to say that the acceleration sensor I used is only capable of measuring up to 6 g according to the datasheet, and therefore I think that the rocket had actually a lot more acceleration, about 9 g or so, but you can see that later. And you can see that the rocket turned over to the left side because the x acceleration increased from 0 to 100, and then it flew down. And let's see how the diagram looks like. This is where the launch started, and you can see at 6 g the acceleration sensor came to its limits, and I guess if you extrapolate this curve at this point, you could go up to a value over here, but I'm not sure about that, and this is just guesstimating. And you may wonder why the x and y values are toggling that strange. This is because the rocket rotated, and therefore the Earth's gravity affected both x and y acceleration, one after the other while it rotated. And this is the rocket laying on the ground. Those are 0 and this one is 1 g. And the altitude is pretty difficult. You have to know that the sensor measures the altitude using the pressure, and because the pressure in the capsule increases with the high velocity, it overshoots a little bit, and this is because of the high velocity. And at the highest point in flight, this is this point here, you can see that when the acceleration reaches 0, then you are at the highest point in flight. And this is where you have the actual altitude, which is a good value. And this should be approximately 20 meters above the starting point. Don't ask me why the altitude doesn't go down to the ground level again. I don't know. I don't know why this happened here. And I'm just guessing that the fire of the solid boosters caused some damage, or something else, I don't know. Maybe you have ideas. Yeah, the rocket unboxing was also pretty funny. and you can see how it looked like. And yeah, that's it from me. Thank you very much for watching. If you like, you can leave your thoughts in the comments below. And oh, one more thing. You may have wondered what we did with the original explosives of the firework. And yeah, I'll show you. Bye bye, have a nice day.
Scheiße. Okay.